Okay, in this video, we're going to look at how we use the ratio test to find the interval and radius of convergence of a power series. Now recall that we said a power series is a series of the form c sub n times x minus a to the n. So again, just to remind you, a is a parameter that is the center of the power series, and c sub n is just a constant that varies depending upon the series. So we are going to look at this example, n equaling 0 to infinity of -1 to the n times x minus 3 to the n over n. So what you see here is that my c sub n is this. Okay, so that's my c sub n there. And this is my x minus 3, so a is 3. All right, so recall that what we said we're going to do is we're going to use the ratio test. So we're going to take the limit as n goes to infinity of the absolute value of, now technically we would include this, however the -1 to the n just is a positive negative sign, and since we're taking the absolute value we don't need to include it, so I won't. We have x minus 3 to the n plus 1 over n plus 1. Now on the denominator I'm going to go ahead and flip it and multiply, so we'll have n over x minus 3 to the n, which will equal, now this x minus 3 to the n will cancel with that one, and I'll be left with 1. So I'm going to pull it out. Now, note that I pull it out in the absolute value, which is important, but also note why I can pull it out. Because remember that in this limit, the only thing that's varying is n. N is going to infinity, and this x minus 3 doesn't have anything to do with n. So times the limit of n over n plus 1. Now, this limit by L'Hopital's rule would be equal to 1, so this would equal the absolute value of x minus 3. And remember, according to the ratio test, for this series to converge, we need this to be less than 1. So we will have x minus 3, the absolute value less than 1. So we'll have x minus 3 is less than 1 and is greater than -1. Just recall that that's how you solve absolute value inequalities, is you have it less than that one and greater than the negative of it. So I can add 3 to both sides, and I get x has to be less than 4 and greater than 2. Now, the other thing to recall in this situation is that the ratio test fails when this equals 1. So this will equal 1 when x is 4, because notice 4 minus 3 is equal to 1, and it'll also equal 1 when x is 2. 2 minus 3 is -1, but the absolute value of -1 is 1. So what I need to do is I need to actually test the series when x equals 4 and test it when it equals 2. So make sure that you show this work when you're working a problem like this. So we're going to say test it, and we're going to say x equals 4. So I'm actually going to plug in x equals 4 into the series. So I get -1 to the n times 4 minus 3 to the n over n. Now 4 minus 3 to the n is just 1, and 1 to the n is just 1, so that's basically 1. And here we have this alternating series, n equaling 0 to infinity, of -1 to the n over n, which we know converges by the alternating series test. Okay, so we know it's going to converge at x equals 4, so we can go ahead and put this as a less than equal to. And now we're going to test what happens when x equals 2. So if I plug in x equals 2, I get n equaling 0 to infinity, -1 to the n. And when I plug in 2 up here, I get 2 minus 3 is negative 1. So I get negative 1 to the n again. Well, negative 1 to the n and negative 1 to the n is just 1. Technically, it's n equaling 0 to infinity of negative 1 to the 2n, which is just going to be 1. So this becomes just the series n equaling 0 to infinity of 1 over n, which we know diverges by the p series. So what we have is an interval of convergence that is from 2 to 4, including 4. So the radius, notice this has a radius of 1 because my center, again, my center is at 3, and I'm going all the way to 4 and to 2. So my radius is 1, but my interval is 4. So that's an example of how we use the ratio test to help us determine if, or sorry, not if, but where a series converges.